Hello, welcome back to PA Academy. So in the previous video, we've looked at what superposition principle is as relates to Coulomb's law, not the one in circuit theory. So we've looked at it, we've looked at the formula that is associated with it. Alright, so now I want to use this example to have more understanding on what the superposition principle is saying. Alright, so before we get into the video, if you are yet to subscribe to PA Academy or you are new to this channel, kindly take out time to click on that subscribe button. It's somewhere at the lower right of your screen or just below the video. You see the option to subscribe. Please click on that subscribe button. Okay. Alright, so thank you very much if you have just done that. Alright, now, so let's look at the example we are having here. It says, point charge 1 millicoulombs and minus 2 millicoulombs are located at, so this is the point, 3, 2, and minus 1, and minus 1, 4, respectively. So calculate the electric force on 10 nanocoulombs charge located at 0.03 and 1. Exactly. All right. So like I explained there, this you can see that we are having a total of 3 charges. So this is different from the Coulomb's charges that we looked at much earlier, where we are just dealing with 2 charges, Q1 and Q2. But here you see we are having as high as 3 charges. So if you remember in that previous video, I made reference to up to 4 charges. Using this example, you can see we have 1 charge here, 2, 3, and then we have about 4 charges. So, and I mentioned it there that you can have, as like I used 4 there, you can have even more than 4, and in this example now we are just having 3. Exactly. All right, so now let's bring out some of those charges. So the first charge we are having, we have, or let me just give you a rough idea of what the diagram is looking like. So just a rough sketch, not the actual diagram. So if we have a charge here, so let's call this Q1, and then we have 2 other charges, so let's call this Q2, and then let's call this is Q3. Exactly. Now let's look at the point charge 1 microcoulombs and 1 milli, not micro, 1 millicoulombs and minus 2 millicoulombs are located at points. So now let's take this Q2 to be the 1 millicoulombs, and then they said at point 3, at point 3, 2, and minus 1. Okay, and then let's take this to be our minus 2 millicoulombs located at points -1, -1, and 4. So like I said, this is a rough sketch of the exact coordinates of the charges, exactly, because we are given in XYZ coordinates. So where this will be the X, then we can start to locate it, but I'm not going to be doing that in this example. All right, so this just, like I did, just a rough sketch to give you an idea. All right, so respectively, so calculate the electric field on 10 coulombs. So this is the 10 coulombs here, on 10 nanocoulombs. So this is 10 nanocoulombs located at 0.03 and then 1. All right, so if you look at this now, you can see that we are having a total of 3 charges, exactly, different from having just 2 charges. Now for us to do this, we are going to look for the the charge here, the force along here. So let's call this F1, and also between this Q1 and Q3, so let's call it F2, and then we are going to add them up. Exactly. So that's just the basic concept between the about the superposition principle when it comes to Coulomb's law. All right, so to start with, we are going to need to calculate the unit vector and the magnitude for that of this F, let's just call it F12 and F13. Exactly. So now let's start with that. So let's start with R12. Exactly. So for this now, if you are to calculate the unit vector, you are always going to make it from, calculate it like this. So this would be 0 minus, don't forget this is our x, y, and z, x, y, z, x, y, z. So the one that is common to the other forces, you can see this Q1 is common to both Q2 Q2 and Q3. So that is the one that you're going to be using, and then you're subtracting every other thing from it. Exactly. So this is how you're going to do the subtraction for this in getting the unit vector. All right. So this will be 0 minus 3. So AX plus, okay, so let me just use a separate color here. So my R12, so I'm dealing with this and then this. So our R12 will be 0 minus 3AX plus 3 minus 2 AY plus 1 minus 1 AZ. Okay, so and this will give us, so 0 minus 3, that's minus 3, so that's minus 3 AX, then 3 minus 2, that's 1, so that'll be plus 1 AY, so you can just write AY, and then 1 minus 1, that'll be 1 plus 1, then so that'll be plus 2 AZ. Okay, so now let's just look for the magnitude also. So that will be the magnitude for R12, so that will be the square root of minus 3 square plus 1 square plus 2 square, and that would just give us 9 plus 1 plus 4, and if you should pull that together, it's going to give us 14. So you're having square root of 14, and then let's just put that there in case we need it. Square root of 14 is 3.7, so let's leave it 3.742. Okay, all right, so let's see what's the units. Okay, so the question did not give us unit, but let's just take it to be meters. All right, so that is for R12. So now we are also going to do for R13. So for R13, so that is going to be between Q1 and Q3. Exactly. So we are still going to be making reference to Q1 because, like I said, Q1 is the link, is the one that connect both Q2 and Q3. All right. So for R13, again, like I said, the one that is common to both of them, you are going to subtract every other coordinate from it. So that will be 0 minus 1 AX plus 3 minus 3 AY plus 1 minus 4 AZ. So this will give us 1 AX, then plus, okay, so this should be 3 minus 1, not minus 3. So plus 4 AY, then 1 minus 4, that's minus 3 AZ. Okay, so now let's calculate the magnitude for it. R13, so that square root of, so 1 square plus 4 square plus minus 3 square. Okay, so we're having square root of 1 plus 16 plus 9. So 1 plus 16 is 17, so 17 plus 9, that's 26. So we're having square root of 26. So square root of 26, let's see. So let's take note of that. That's 5.099. 5.099 meters. Okay, so if you are finding value in the video, please give it a thumbs up. Click on that like button. All right, so now that we've gotten the unit vectors and then the magnitude, so now let's bring out the formula that you have to use. So to calculate for the force, it does be Q1 q2 over, so that's for this first part, q1 q2 over 4 pi e naught multiplied by r12 all square multiplied by the magnitude r12 over, by the unit vector over the magnitude of r12, then plus q1 q3 over 4 pi e naught multiplied by the magnitude of r13 square multiplied by the unit vector r13 over the magnitude of r13. Okay, all right, so that's the formula that we are to use, but instead of using it straight up like that, so instead of using it straight up like that, it can be a little cumbersome, although this might be even easier because we just have just 1 and 2 exactly. But once you are dealing with 3 and 4, and if you decide to do it like this, it might just take you a longer time. So we have some things that are common, so we are going to factor it out to make our work much more easier. If you look at what we are having here, you see that this part that I circled here is the same thing with what we are having here exactly. So we can factor it out as q1 over 4 pi e naught into brackets q2 over r12 square multiplied by the unit vector r12 over the magnitude of r12 plus q3 over 4 pi e naught multiplied by the magnitude of r13 square, then multiplied by the unit vector r13 over the magnitude of r13. Okay, so it's much to make our work much more easier doing it like this. So all right, so now let's put in the values. Okay, so when you are putting the values also, you need to be careful so that you don't just make mistakes with values. Okay, so again, our q1 is 1 millicoulombs. So let's go back to it. Let's see. So just take note of those values. That's 1 millicoulombs. That 1 millicoulombs is same as having 1 times 10 raised to power minus 3. So then 10 nanocoulomb, our q2 rather, is 1 millicoulombs. Then for our q1 it's 10 nanocoulombs, which is 10 times 10 raised to power minus 9. I've talked about it in the other video, in the previous one. Then minus 2 millicoulombs is minus 2 times 10 raised to power minus 3. All right, so now let's go and put in all of these values in the formula that we are using. So again, our q1, which is 10 times 10 raised to power minus 9 over 4 pi. So let's use times 8.854 times 10 raised to power minus 12. Like I said, that's the constant. Then open the brackets. So our q2, so again, let me go and confirm q2. That's 1 times 10 raised to power minus 3. 1 times 10 raised to power minus 3 over, so this now, the magnitude of r12 square. So this is r12. So if you should square it, we are going to be getting 14. So this will be over 14. Okay, so multiply by, so this our r12 is this exactly. So that's minus 3 ax plus ay plus 2az. Okay, so multiply by, so let me put that in bracket, minus 3 ax plus ay plus 2az, then over r12, the magnitude of r12, so 3.742 3.742. So then plus, all right, so Q3, let's see, our Q3 is minus 2 times 10 to the power minus 3. So let me put that in brackets. So minus 2 times 10 raised to the power minus 3. So divided by 4 times, okay, 4 times, or let me just put it 4 pi times 8.854 times 10 raised to the power minus 12. Okay, so just a minute. So at this point, we don't need to add this 4 pi in naught. So I think I still went ahead and add it again. So we don't need to add that again. So like I said, the reason why we factor it out is to make our work much more easier. So this will be R13. So the magnitude of R13 square. Okay. So now let's continue. So what will be at the denominator here will be R13 square. So let's look at R13. So this is R13. So if you should square it, you are going to be having 26. So that will be over 26 multiplied by, so R13, this is the value here. So we are going to be having it here. So let me put this in brackets. I hope this space will be enough. So that will be AX plus 4AY minus 3AZ. Okay, then over the magnitude of R13. So what was that magnitude? So that's 5.099. 5.099. All right. So now let's use our calculator to find the value of what we are having here. So times our F. So let's use our calculator to look for what we are having here. So this will give us 89.877. So then we open our square bracket. Now at this point, I'm going to take you through step by step to break this down, because this is just mathematics. It's just, but I don't just want to use just mathematics. I want to take my time to simplify all of these things, and not just to give you the final answer. Because if you miss a particular step here or any step here, if you mix your calculation here, it will affect your final answer. So just follow along. Now the next thing I want to do is this 14 multiplied by 3.742. So what I'll do is 1 times 10 to the power minus 3 divided by the product of this. So if you do that correctly on your calculator, you are going to be getting 1.909 times 10 raised to the power minus 5. Exactly. Then we bring in minus 3ax plus ay plus 2az. Okay, so then plus, so if we should multiply this now, 26 multiplied by 5.09. Exactly. So once you multiply it, whatever you get, then you are going to have minus 2 times 10 to the power minus 3 divided by the product of this. Are we good? So once you do that correctly, you are going to be getting minus 1.509. So do make sure you confirm all of these calculations from your own end also. Times 10 raised to the power minus 5. Very good. So don't forget this negative sign is very important. So don't forget, because we are having a negative sign here. Okay. All right. Then we bring in our value ax plus 4ay minus 3az. Okay. And then our square brackets. All right. So the next thing is, so let's continue. Our f is 89.877. Now another thing you need to note is that the 89.87 that we are having here is for everything inside this square bracket. So don't do the mistake of using it to just multiply some random values here. It will affect your final answer. So those are some things you need to take note at this point. All right. So the next thing I want to do is I'm going to use this 1.909 times 10 to the power minus 5 to multiply each and every values inside this bracket. Okay, so 8.877. So let me just use a different color so that you can differentiate the lines or the steps. So our F is 89.877. So if I should use 1.909 times 10 to the power minus 5 to multiply minus 3, I'll be having minus 5.727 times 10 raised to the power minus 5 AX. So if I also use this to multiply AY, so that would be plus 1.909 times 10 raised to the power minus 5 AY. Then if I should also use it to multiply it 2, that would be plus 3.818 times 10 raised to the power minus 5 AZ. Very good. So we've used this to multiply everything inside this bracket. So let me just put this in brackets. So we still have the square brackets also there. Then plus, so I'll use minus 1.509 times 10 raised to the power minus 5 to multiply everything that is inside this bracket, exactly because they are together. So that will give me plus minus 1.509 times 10 raised to the power minus 5. Okay, so let me just write it on another line because of space. So that will be plus. So this plus that is here is the same plus I'm having here. Okay, so pay attention to this sign also. So if I should use this minus 1.509 times 10 to the power minus 5 to multiply AX, so it will still give me minus 1.509 times 10 raised to the power minus 5, then AX. So I will also use the same value here to multiply 4AX. So that will give me minus 6.036 times 10 raised to the power minus 5 AY. Then lastly, I'm also going to use this minus 1.509 times 10 raised to the power minus 5 to multiply minus 3AZ. Note, this is minus 3AZ. So the minus and minus will be plus. So that will be plus 4.527 times 10 raised to the power minus 5 AZ. Okay, so let me close this and then introduce the square bracket. All right, so next thing I'm going to do is, you see this bracket here, this square bracket is from here to here. So now the ones with AX, this AX is going to add up with this because you can see there's a plus sign here. There's a plus sign here. So we are going to add up, so that means our F is will still be 89.877. So your 89.877 will still remain into brackets. Now let's add up minus 5.727, which is this, times 10 raised to the power minus 5 AX plus minus 1.509 times 10 raised to the power minus 5 AX, because they are both having AX. Exactly. So if you do that correctly, you are going to be having minus 7.236 times 10 raised to the power minus 5 AX. So please don't let this calculation to piss you off. I'm taking my time to go through it. So make sure you go through it together. You confirm it also from your own end. Okay. Then the next one is we are going to add up 1.909 times 10 to the power minus 5 AY with plus this minus 6.036 times 10 to the power minus 5 AY. So this is 10 to the power minus 5. So this will give us minus 4.127 times 10 raised to the power minus 5 AY. Okay. So now let's also add up this with this, and that will give us plus 8.345 times 10 raised to the power minus 5 AZ. So now let's close this. So if you are finding value in this, please give it a thumbs up. Okay, so now we are almost done. So that means we can go ahead, and that means our F. So forgot to put. So now we can use the 89.877 877 to multiply everything that is in the brackets now. You can see we're breaking it down. So 89.877 multiplied by minus 7.236 times 10 raised to the power minus 5. So again, if you are typing this in your calculator, make sure you type it correctly. So if you type that in your calculator, you are going to be having minus 6.503 times 10 raised to the power minus 3. So if you also use this to multiply minus 4.17, you are going to be getting minus 3.709 times 10 raised to the power minus 3. Also use 89.877 to multiply 8.345 times 10 raised to the power minus 5, and that will give you plus 7.500 times 10 raised to the power minus 3. Okay, this will be ax, ay, then az. Okay, now don't forget, you can decide to add your unit here, your Newton, but we can't stop there, because if you notice that we are having 10 raised to the power minus 3, 10 raised to the power minus 3, 10 raised to the power minus 3. Okay, so let's just factor that out. So that means our f is minus 6.503 ax minus 3.709 ay plus 7.500 az. So let's put everything into brackets times 10 raised to the power minus 3 Newton. Are we good? All right. Now you also recall that 10 raised to the power minus 3 is milli. So milli is 10 raised to the power minus 3. So with that, we can have our answer as our f is equals to minus 6.503 ax, don't forget the bar at the top, minus 3.709 plus 7.500 az millinewton. And what we are having here is the answer to the question. So this is our final answer to this particular question. So this is the force. So let's go back to the question a bit. So just a minute. So that is the force that is acting on the 10 Newton Coulomb charge that is located at this position. So from this point where we started doing this calculation, exactly, so you have to be very careful there. Make sure you confirm and verify it. And your answer might be a little different from mine in terms of approximation, but it will still be very close in terms of this 6.5 or 3.7 and then 7.5. So thank you very much if you watch it to this part. If you find value in it, give it a thumbs up, and do make sure you subscribe to the channel. And shout out to His Royal Secretary that is disturbing me here. I'm saying it live. I don't want to just mention your name.